Welcome to my presentation discussing plastic recycling, and more specifically, attempting to answer the question, is it worth it? Firstly, we need to understand what plastics are. They are a synthetic material made from a wide range of organic polymers, and a polymer is a macromolecule made from linking repeating small units, or monomers. This can happen through either a step growth mechanism or a chain growth mechanism. Chain growth is where monomers are added one by one at the end of a growing chain. This has a three-step mechanism. The first step is initiation, where a reactive species is formed, which then reacts with the first monomer to generate a reactive polymer end group. Then comes propagation. The reactive end group reacts sequentially with more monomers, extending the chain. Finally, there's termination. Something happens to deactivate the reactive end group, hence stopping the polymerization. Step growth is where the monomers and growing chain have reactive groups, so more small chains are formed at the start before joining together to increase chain length. For this you need two monomers with complementary reactivity, such as a dicarboxylic acid and a diamine. One example of a plastic is PET. This is the most common thermoplastic polymer, which is a plastic made up of polymer resins which softens when heated and hardens upon cooling. Some of its uses are in fibres for clothing or containers such as water bottles. Properties which make these possible are it being strong and rigid, its low moisture absorption, and low sliding friction. We also need to understand how we recycle plastics. There are two main types of plastic recycling, mechanical and chemical. Mechanical recycling uses grinding, washing, sorting, and reprocessing to repurpose plastic material and is the most common traditional method. Chemical recycling is the process of recycling plastics through chemical change, forming a raw material that can be used to manufacture new products and is suitable for some plastics which can't be recycled using a mechanical method. Chemical recycling is a relatively new method of waste management, which turns plastic waste back into base chemicals. There are different types of this. Two are feedstock recycling and depolymerization. They are based on breaking down the long hydrocarbon chains present in plastics into shorter hydrocarbon fractions or into monomers using chemical, thermal, or catalytic processes. But purification uses solvents to remove additives from the polymers. Mechanical recycling involves a collection of recycling from houses, businesses, or schools, which are then taken to a material recovery facility, or a plastic recovery facility, where plastics are then sorted from other materials either through manual picking, screening, or using devices which are able to automatically separate. This is usually done based on size. They are then shredded into smaller pieces and washed, which helps to remove adhesives or residual waste before being extruded, which is the process of melting down the plastic and forcing it through an extruder. As the plastic exits the extruder, it is cut to form pellets, which are then sold on to manufacturers. Not all plastic can be recycled though, so what types are able to be, and how do we know? There are only three types of plastic easily recyclable anywhere, and that is PET, HDPE, and PP. Three other types are recyclable, but only at specialist points: PVC, LDPE, and PS. Any different plastic isn't easily recyclable. This is down to how they are made, more specifically, that thermoset plastics can't be recycled, but thermoplastics can. In households, for example, we can tell what is recyclable by a symbol they have on the plastics. This is shown on the screen. So in number 1, PET, it's recyclable. This system isn't easily remembered though, which leads to plastics ending up in the wrong bins, leading to contamination. Now that we have explored the basics behind plastic recycling, we need to consider the environmental impacts. The recycling process as a whole reduces the plastic that ends up in landfill or the oceans, and hence reduces the problem of soil pollution and microplastics, which is when plastics break down into small pieces, typically in oceans. These are harmful to aquatic life. It also means that less newer plastics are needed. However, waste is often not separated properly and the process is inefficient and expensive, while requiring a large amount of energy to melt the plastics. They also release volatile organic compounds, which are compounds that evaporate easily at room temperature. When combined with nitrogen oxides, they react to form ground-level ozone, or smog. This contributes to climate change. While non-recyclable plastics are often thought of fully in a negative light, they do have some positives, such as being cheaper to manufacture, so more accessible for lower income countries, and they can be used to generate electricity or fuel. But the negatives do still exist, and they can take up to 500 years to break down. Considering everything we have covered, I believe that plastic recycling is worth it, but better communication about what is and isn't recyclable is needed, along with more research to reduce the cost and increase efficiency. This research could lead to advancements in plastic recapture systems, such as trying to get plastic back out of the oceans. We also, as a society, need to increase efforts to reduce our reliance on single-use plastics.